Hello Internet, I'm Tom and I'm from the newly resurrected Boffnet. I can't speak for everyone in this channel, but I can say that the reason that I've left you for so long is this camera phone computer connector cable of mine. I deliberately left this at home when going back to school last term because I kind of had A-levels. I prioritised A-levels over you, Internet, and I can only say that I'm sorry and that I will never prioritise A-levels over you again. By the way, Tom, I like the new look with the headphones and the hair and everything. I'm just doing the same old thing. Maybe I should switch it up or something. No. No. No! That's quite good. Oh, this is what I started with, isn't it? What an anticlimax. Luckily, this isn't Boffnet literature, so we don't have to take that as some sort of horrible, prescient metaphor.
It's Boffnet Maths.
Let's switch angles. There is a quick and easy way to find out whether a number divides by 7, which I learned in primary school. Take a number, chop the last digit off the number so you get 2 new numbers, multiply the number at the end by 2, and subtract it from the bigger number. You will now have a smaller number. If this number divides by 7, then so does your first number. You may need to repeat this step a couple of times to end up with 7, minus 7, or 0, which all very clearly divide by 7. Let's call these numbers, I don't know, deadly numbers, where a deadly number can divide by 7. I recently worked out how this actually works. To show you, I'm going to need to do some algebra. Take 2 whole numbers, a and b. In our example, a and b were the 2 numbers you got when you chopped the first number in half. You can now do 2 things with a and b. You can combine them in a way that gets the number at the start, 10a plus b. You can also combine them to get the number made after one iteration of the trick, after one repetition of the trick, a minus 2b. What the trick says in this algebraic language is that if a minus 2b is deadly, then 10a plus b is also deadly. Now comes the fun part. If we take 10a plus b, then 10a plus b again, and then a minus 2b, and add them all together, the b's cancel out, and you get 21a. Now this number is absolutely certain to be deadly, no matter what a is, because 21 is 7 times 3. And we've already said that a is a whole number. So whatever 21a is, there's a factor of 7 in there, somewhere. Now, assume that you know that a minus 2b is deadly. I'll come back to this because this assumption is important. In this case, you've got a deadly number, plus something, plus that same thing again, all equaling another deadly number. Now, a bit of algebra shows you that any number doubled, which added to a deadly number is a deadly number, must itself be a deadly number. So the something, which in this case is 10a plus b, must also be deadly. So what we've done is proved that 10a plus b must be deadly, assuming that a minus 2b is deadly, which is what we said at the start, and this is what the trick is based on. It's cool, isn't it? This all works because when you add up the algebra, you get something which must necessarily be deadly, and you work backwards from there. Knowing this, though, you can adapt this tool to work out if numbers are divisible by other numbers. You can't change the 10a plus b, because that's the starting point, but you can change the other number. Since all of this lot add up to 91a, which is 7 times 13, you can work out if a number is, say, an unlucky number by taking off the last digit, multiplying by 9 and subtracting. You can work out if a number can divide by 17 by taking off the last digit, multiplying by 5 and subtracting it. Of course, for large numbers, this stops being a useful test and starts just being a curiosity, because bigger numbers generally mean more time-consuming maths. But for smaller numbers, especially 7, I found it quite useful. Unless there's a calculator to hand.